Hello and welcome to Data Analysis and Visualization with Python. This is the video 4 in the series and we are studying Numpy library, and this is the part 2 of that. So let's continue where we left off and let's take a look at some of the functions that we can use to initialize Numpy arrays. Okay, so first of all, Numpy offers a number of functions that are used to generate arrays with initial placeholders. Sometimes we want to create an array of a certain shape without any specific data. Numpy offers several functions to create arrays with initial placeholders, such as zeros or ones. So let's create a zeros array. What we're gonna do is equals numpy dot zeros, and in brackets we're gonna give a tuple, which is going to be the shape of the array that we want to create. So let's go ahead and enter 5 by 5, so 5 rows and 5 columns, and then we're going to print this out. So we have a array with this shape, so 5 rows and 5 columns. This is a two-dimensional array and it's all filled with zeros. We can also generate array that basically is all ones. So what we're going to do is ones array equals numpy dot ones. Let's suppose 3 by 2. You have to make sure that you are giving a tuple inside these brackets and not just the values, because the ones or zeros functions basically accept tuples. So let's print this out and see how it looks like. Okay, as you can see, 3 by 4, and we can create basically an array with random numbers as well. To do that, we can just say print numpy dot random dot rand, and in this we just give a shape, let's say 2 by 3, and so this is an array with random numbers with the shape 2 by 3, 2 rows and 3 columns. Of course, you can create arrays with just one value as well. So print mp dot random dot rand 2020. All right, so this is just a one-dimensional array. Zeros, ones, and rand functions usually are often used to create example arrays, or sometimes as a placeholder while you're processing some data out. We can also create a sequence of numbers in an array with the arrange function. So what it does is basically we have a starting value and we have a ending value, and if I print this, what happens is that there will be an array that will be created starting from 10 and ending at 39. We can also add another parameter, np.arrange 2, 20, and 2. Now the third parameter is the difference between each consecutive numbers, which means that if I now run this, so it creates an array with a difference of 2 in each element. So the starting point is inclusive and the ending point is exclusive, which means that won't be included in the array. Usually if there was no jumping parameter here and if I ran that, the array would go up to 19. Okay, so let's move on to accessing and changing arrays, their rows and their columns. It's basically about indexing and accessing values from Numpy arrays. What I'm going to do now is first of all create a sample array, np.array 1, 2, 3, 4, and so on, some random values. Okay, so then I'm going to create another array, which is going to be a two-dimensional array, or a matrix, as you would say. Sorry, I forgot to add the parentheses, the part of the syntax. Okay, so a list, and inside that we have 2, 3, 1, 4. Okay, let's run this, make sure we have no errors, and okay, let's see here's the shape of B, which is going to be 3 by 4, which means there are 3 rows and 4 columns. Let's just print out the B array first. We already know how the array A is going to look like, so so we can see right here 3 rows and 4 columns. So to get a specific element of an array, we can basically use normal indexing like in lists. Okay, so the array B has a shape 3 by 4, but indexing starts at 0. So if you want to access a element, let's suppose 6, we would normally think that this value is at second row and third column. But if you want to access this value, what you're going to do is B 1 and 2, right? Because indexing starts at 0, so this is the 0th row, this is the first, and this is the second row. Similarly, this is the 0 column, this is the 1 column, this is 2, and this is 3. So we have to get this value 6, right? So if I run this, it should return 6. Alright. Alright, similarly, we can get the value, this one, there are 3 ones here. So notice we want this one. So what we're going to do is enter here B, second row and second column. So if I print this, it should return 1, and this is this one. Moving on, specific row. Let's get a specific row out of the array, and the way we can do that is basically which row we want. Like B, let's suppose we want the first row, which is going to be 0, and in the second index, what we're going to do is just write a colon here. So that basically indicates that we only want the entire row and not a specific row. So if I run this, it should basically return 2, 3, 1, 4, which is the 0th row of the array. Similarly, in the exact same way, specific column out of the array. So what we do is B, we put colon here, and in the column section we want, let's suppose, the last column, which is going to be 3. So if we print this, 4, 3, 4, so you can see 4, 3, 4. This is the third index column of the array B. Okay, so there is a little bit of tricky indexing. What we're going to do is we have let's suppose we have an array, long array, which is I've created, and this array basically looks like this and has a shape 3 by 12. So 3 rows and 12 columns. Remember, the index is as follows. However, the rows go up to 2 index and the columns go up to 11 index. So from 0 to 2 and from 0 to 11. Now recall above that we use the arrange function to create some sequences of arrays which basically contain data from the given ranges, from the first one inclusive and the second one exclusive, from 2 to 19, for example, here. So if we put and recall that we studied that if you put a, let's suppose, 3 here, and you can see here that the first value is star, the second one is stop, and the third one is step. So values are generated within the half open interval. In other words, the interval including start but excluding stop. And so we can basically use the exact same thing with indexing to get values, specific range of values from a row or a column. So let's get values from a specific row. So let's suppose I want to get values from this up to here, right? Okay, so what we're gonna do now is we're gonna print long array, and in index values, for example, let's suppose we want to retrieve the values in the second row from 32 to 11. So how many elements are there? So 0, 1, 2, 3, 4, and 5. So we'll type the index ends at 6, which means this value, right? So long array, the row number is going to be 1 because 0 and 1. So the values we want is from 0 to how many elements? 0, 1, 2, 3, 4, 5, and so we add 6 to get 11, right? If you want to include 11. So if you go ahead and do 7 and run this, so we get 32, 52, 12, 35, 43, 11, and 66. You can actually use the jump value as well. So if I add 2 here, now the values are going to be 32, 12, 43, and 66, hopefully. Let's run this. Okay, so I forgot that this was supposed to be a column, just like the above. So 32, 12, 43, 66. So this was a little bit of information about how you can retrieve or get values from the Numpy arrays in different ways. Okay, so basically you can change specific elements, rows, and columns of an array in exactly the same way that you accessed it. So we know, for example, we want to change the first value of this array to 100. So of course, what we're gonna do is long array 0, 0 equals 100, right? And if I print long array now, what happens is that the first value has been changed. Okay, so let's change some more values in the arrays. Let's say long array 2 and 5 equals to 1000, and let's run this and print as well. As you can see, the first and the second row and fifth column is changed. The element at second row and fifth column has been changed. You can actually change the entire rows of an array. So what you're going to do is, let's change a full entire row of this array. Let's suppose 0, 1, 2. So let's change this row. What we're going to do is we're going to long array 2 2 comma column. So this tells us to select the entire row equals to 5000, right? So if we print long array now, you can see that the second row is changed. And so if we want to change the column of a array, you will do it in exactly the same way. Long array column, and then let's suppose we want to change the from 0 to 11th column. Let's so 77, 65, and this 5000, the values are going to be changed. 11 equals to, let's suppose, 999. Let's run this and print long array, and we can see that the 11th column has been changed. So I want you to pause the video, for example. So I want you to pause the video right here for a brief moment and go ahead and try to change the second row try to change the 0 1, the row at one index starting from 0 to 5, right? I want so change these specific values of this particular array, and once you have found the solution, unpause the video. Cut the entire fucking challenge part. Okay, so now let's suppose that I want to change the row at one index starting from 0 to 5, right? I want to change these values to, let's say, 100, right? So what we're going to do right now is long array. So the row number is 1, and the values from 0 to 5 are going to be 1200. So if I run this and print long array now, you can see that these values in a row have been changed to 1200. Okay, so this is all for this video. Today we learned about the basics of Numpy array, making Numpy arrays, two-day arrays, dimensions and shape of the Numpy arrays, helper methods like dot shape, dot data types, dot dimensions, and then dot and dimensions, and then generating placeholder arrays, and then accessing specific values, rows, columns from an array, and then we learned about editing specific values and parts of arrays. I think this is more than enough things to practice in one video. I'm going to post some links in the description so you can read more about them and practice playing with NumPy arrays. In the next video, we're going to continue learning more about NumPy library and some of the advanced things you can do with NumPy arrays. Thank you so much and see you in the next video. So I'm going to talk a bit about something interesting in accessing values through indexing, right? So we're just going to start off by making an array, but this time I'm going to use np.random.randint, which basically returns uh, an array with the random integer values, so from ranging from 1 to 101. Let's say the size of the array is going to be 5 by 5, and let's print this out. So I want you to take a look at these two statements and see what they're gonna do. So what's happening in the first statement is that we are selecting the first 3 rows and then selecting their third columns. But in case of second statement, we are basically selecting the first 3 rows and then trying to access the values of their corresponding columns from third column to fourth column, and of course the fourth column will always be exclusive, so the only return value will be the third column. But the difference is that in the second statement basically preserves the way the columns were stored. And so this is just an example of how the shape of data is just an abstraction which we can basically put on top of the data that we are working with. Okay, so before moving on to the operations on array using NumPy, I want to talk a little bit about how data is abstracted for us when we are working with arrays, and our understanding of data is often abstracted when we are basically trying to understand it. So for now, we've been working on, for example, 2D arrays, and we can think of 2D arrays as matrices, and we often think about two-dimensional arrays being made up of rows and columns, but you can also think of these arrays as just a giant ordered list of numbers, and the shape of the array, the number of rows and columns, is just basically an abstraction that we have for a particular purpose. Actually, this is how the images are stored in computer environments, basically arrays in the form of matrices. So I have a small demonstration for you, but you don't have to follow it or anything while I do it, but you can understand throughout the demonstration what I'm talking about. So for now, what I'm gonna do is import a bunch of stuff, right? Import CV2. Of course, you don't have to follow this, and just sit back and try to understand what I'm trying to demonstrate here. So I imported basically a few modules that will help me load an image into an array, right? So because this is Google Colab, I'm gonna use uploaded equals files dot upload to upload an image. So if I run this right now, it will ask me to choose files, which I will do. So I've uploaded the file now, and what I'm gonna do now is I'm gonna load this image into, and if I try to show this image on Google Colab, it should appear. Okay, so we have a nice image. So what I'm gonna do is, first of all, I'm gonna convert this image into grayscale because we want two-dimensional arrays and not three-dimensional, and a colored image is usually imported as three-dimensional image. Okay, so we have successfully converted the image to grayscale. Now what I'm going to do is convert this image into a numpy array. So what we can do basically is we can basically write image array equals np dot array image. Let's print image array. Okay, so we have the array, right? This array basically represent this image, and each pixel in this image has a numerical data that's inside this array. So what I'm gonna do is I'm gonna create a mask, right? So I'm gonna create a mask called void np dot full image array dot shape 100. Okay, so what basically happens is that np dot full basically is a function of numpy, which takes two parameters. The first one is the shape of the array that you're going to create, and second is the fill value. Recall in the past I taught you about how you can create different kinds of arrays with NumPy, like random arrays, zeros and ones. Similarly, you can basically create an array full of the data that you want. So in this case, if I now print the void array, what happens is basically this basically returns an array that's shape is exactly the same as image array, right? But all the values inside it is 100. So now what I'm gonna do is I'm gonna do image array equals image array minus void. So what's going on here is that all the values, we're gonna extract 100 from them. We're gonna subtract void from the image array. So I'm gonna run this, and then I'm gonna display the image. So cv2, so I'm gonna display this array in the form of image. So let's see if it works. Okay, so you can see how by subtracting the 100 from each of these elements, the color of the image has changed. Basically, we changed the numerical data and changed the color of image, right? This was the original grayscale image, and when we subtracted minus from the array of this image, we got this result. So what I'm trying to show you right now is that the numpy arrays are basically abstractions on top of data, and that data could mean basically anything, and every data has an underlying format. And so we have performed operation on an array that was basically numbers, and used those number ordering tools to change the look of data in the form of an image. In some ways, this course is basically about data and abstractions that we can build on top of data, from individual byte representations to complex neural networks of functions or interactive visualizations. The point of understanding is to further understand what the data means and transform it into different representations to be used for getting something meaningful out of it. So let's take a look at a little bit of some operations that we can perform on NumPy arrays. Um, so basically we can add two arrays. Right now we have created two arrays, 1 and 2, using the np.random.randint. So it's an 8 by 8 arrays of random integers. What we can do is we can basically say s equals array 1 plus array 2, and we can just print s, right? It basically adds the arrays. We can basically multiply as well. So this does the element wise multiplication of arrays. We can use many aggregate functions on NumPy arrays as well. For example, m.min. There are a lot of functions and operations that you can perform on array, but I think that is best provided in the form of reading format, so it's more easier to remember the functions and syntax. And so after this introduction to the NumPy, what I'm gonna do is I'm gonna first post some information and documentation, link to documentation of NumPy, so you can read and practice. Furthermore, I'm gonna add a lot of challenges and things that I could not cover in this week. I'm gonna put challenges and solutions and questions and answers to related to NumPy library. And of course, this is not all of the NumPy library. There's a lot of information that you need to discover on your own and practice a lot on different data sets, which in the next week we are gonna take a look at. And we're also going to be taking a look at the main library called the pandas library. And so with that being said, the rest of the material will be in the form of notebooks and notes and links and so on. There is a lot of content for you guys to read, so take a look at that before moving on to the next videos. I'll see you in the next videos.